Good afternoon, everybody. They said that I wasn't going to beat around the bush, but I do need to say it's just wonderful to be here in Madrid. So thank you for everybody being here. It's so nice to meet each and every one of you and to have the opportunity to be here at DevCon once again. The talk that I'm going to give you today, you may remember earlier we had Misael Neto talking to us a little bit about cloud native. I'm going to be telling you a little bit more of a technical background on cloud native, a little bit more of a deep dive. And this is a topic that you may not have as much context on, but don't worry, whether you know a lot about something like Kubernetes or cloud native, or just a little bit, I'm going to try to bring everybody along with us in a very didactic, friendly way. So without further ado, let's go ahead and start with some audience participation. I know coffee is coming in a little bit, but let's be energetic. By show of hands, and yes, raise your hand, who has run Liferay? I hope most people in here raise their hands. Good. Wonderful. Okay. We're going to build on top of this now. Who has run Liferay on someone else's computer? Maybe troubleshooting a little bit. Good. All right. Time to see the real hardcore people in the room. How about who has run Liferay on someone else's computer remotely? Good. Wow. Actually, a lot more than I thought. If you've done all three of these things, you have done the functional equivalent of running Liferay on the cloud. The point that I want to make, though, is that running Liferay on GCP's computers remotely, or running Liferay on AWS's computers remotely, or running Liferay on any cloud provider's computers remotely, that's what we're doing when we're running Liferay in the cloud. And GCP's computers and AWS's computers and every other major cloud provider's computers all have one thing in common. They all support Kubernetes. But what is Kubernetes? Don't worry. I'm going to bring you all with me. I'm going to tell you. Kubernetes is the standard orchestration runtime of the cloud. And when we say orchestration, what we really mean is highly coordinated automation of a complex system, such as an entire application architecture. So let's flesh that out a little bit. Kubernetes leverages containers. And I'm sure we all know about containerization, Docker. If your app can run from a Docker container, then it can run on a Kubernetes environment. And when we look at the code that runs a Docker container on a Kubernetes environment, it looks something like this. This is a Kubernetes manifest. It's a declarative definition that we can run and manage using the Kubernetes control plane. This particular manifest runs Nginx, which is a load balancer. You can see that it pulls the Nginx image down from a registry, in this case Docker Hub by default, version 1.29.2, and it runs that container in something called a pod. Now things get really interesting when we start to bundle these manifests together. We can use a tool like Helm to package multiple bundles, multiple manifests together, representing each piece of our application architecture. And these are all just static files. These are all just files that we are writing ourselves and keeping statically on our computer. And that means that it's all reusable. We can actually template this, and we can stamp out as many deployments as we need with custom parameters per deployment. But what does that have to do with Liferay? Well, Liferay can run from a Docker container. Here is a Kubernetes manifest that runs DXP. It pulls DXP down from Docker Hub 7.4.13 and runs it in a pod. And you should probably be aware that none of this is new. This is actually how our PaaS solution works behind the scenes. So what does all of this mean? Well, we already established that every major cloud provider, think Google, AWS, Azure, all provide Kubernetes services. So if an application can run on Kubernetes, then of course it can run on any major cloud. In other words, if we implement a set of Kubernetes manifests that run Liferay, then we can use that bundle of manifests to deploy Liferay to any cloud we want. And because every major cloud provider offers managed database, search, and object storage services, then we can make Liferay GCP native by building our infrastructure on GCP. We can make Liferay AWS native by building our infrastructure on AWS. Indeed, we can make Life cloud native by building infrastructure on the cloud. Now, we've talked about representing a Liferay runtime with Kubernetes manifests, but let's talk a little bit about those service dependencies. How can we build this infrastructure on our cloud provider? One way is that we can use an infrastructure as code tool like Terraform. Remember how I described the power of static files making our Kubernetes-based deployments reusable? That also applies to the infrastructure when we use a tool like Terraform. Let's illustrate this using AWS, just for example. Terraform provides AWS modules that we can use to build AWS infrastructure from a static file simply by declaring the resources and the configurations of those resources that we wish to create. And Terraform provides this for other cloud providers as well, not just AWS. But let's go ahead and take a look at what a Terraform file actually looks like. So this is a Terraform module, and this particular example creates a Kubernetes cluster on AWS's Elastic Kubernetes Service, or EKS. This cluster resource provides the Kubernetes infrastructure that we need to deploy our Liferay application manifests. As I mentioned before, Terraform is what we call infrastructure as code. It makes our infrastructure deployment static and reusable. And we're not limited to Kubernetes clusters. We can create any resource that we need, all sorts of infrastructure resources, using Terraform. We can define the entire infrastructure baseline that we need in order to run Liferay, including the database, object storage, and search dependencies, as well as any other cloud services that you wish to leverage. And when we run the Terraform tooling, it creates that infrastructure baseline for us exactly as we've designed it. And once we've terraformed our infrastructure, then we can deploy our Liferay Helm chart onto it. It's a two-step process. For those of you that like taking pictures of diagrams, I've made this specially for you. You can see that we have step one. We are deploying the infrastructure using Terraform. And then step two, we are deploying Liferay using a Helm chart. So you've officially deployed a cloud-native Liferay. What now? Well, you can manage your Liferay using a tool like kubectl, or you can use your cloud provider's web console, or the bevy of other cloud tools that allow you to manage your runtimes. You can monitor your Liferay application using observability dashboards on your cloud provider console, or you can also deploy something like Prometheus and Grafana and have a custom setup exactly the way that you need it. Third, you can leverage other cloud provider features, all those cutting-edge features that your cloud provider offers. Think auto-scaling, for example. Perhaps you want to use AI-powered predictive auto-scaling to fine-tune scaling behavior automatically. You can leverage that directly from a cloud provider like AWS or GCP, or you can use a third-party Kubernetes native solution on the cluster. You can even deploy your own implementation if you need special custom behavior. You're in complete control. The sky is the limit. So I guess you're wondering if we built this solution, or if I'm just telling you about it. Of course we built it. Now, the emoji every time. Let's actually watch it in action together. Now, I wasn't brave enough to do a live demo, so I hope you'll forgive me. I know other people, their live demos have been going wonderfully, which is unique. We don't normally have that. I just recorded mine, but I'm going to coach everybody through what's happening, okay? So first here, we're going to log into our AWS CLI. This is one of the prerequisites because, of course, we need to be able to manage our AWS resources. So we've logged in, and now that we've authenticated, we'll clear the terminal, of course, because I'm trying to be very organized to make this easy for you to follow. We're going to download our Terraform scripts that we actually have on the Git repo, Liferay portal. So once we've downloaded those, we do a shallow download, by the way. You don't have to download the whole repo, just the Terraform files. Now we're going to go to the EKS module because we need to create our Kubernetes cluster. So we'll initiate the Terraform state. And what this is going to do is it's going to validate our Terraform plan, and it's also going to download all of the modules that we need in order to create the resources on AWS. So once all of the modules are installed and our plan is created, then we'll clear the terminal again, and we will apply that Terraform plan. Now, a Terraform apply of the types of resources that we're creating may take between 5 and 10 minutes. So fortunately for you, I'm not doing a live demo. I actually fast-forwarded for you. There we go. So you can see here we've created our cluster. We've also created a service account to go along with it, as well as some networking. Now we're going to take the outputs from our cluster, and we're going to insert those as inputs so that we can create dependencies using a separate Terraform script. That's going to be, like I said, our managed services that we're using for search, database, and object storage. But before we do that, we need to add our cluster to our kube config so that we can access it from our local machine. So we're doing that real quick. And now that our kube config is updated, we do also just need to set a local path to make sure that our kube config is visible to our dependency script. Now we can navigate over to our dependencies module, and then we can initiate that Terraform plan and apply it as well, which you'll see. Beautiful. Clear that, and then we will apply it. And it will not only create the search, database, object storage that we need, it'll also hook up the service accounts and all of the IAM that we need, as well as any extra modules that we wanted to create as part of our infrastructure. And those are going to be the two basic steps for getting us started, having our infrastructure baseline onto which we'll be able to deploy Liferay using our Helm chart. So our cluster is created, our managed services are created. Now all we need to do is to save our service account to a variable here so that we can add it to our Liferay deployment so that Liferay can access our managed services. And now for step 2. First, we are going to define a variable for our registry. In this case, we're using the Docker registry, the Liferay artifact registry there for our DXP chart. And then we're selecting our DXP image tag as well. We're going to use 2025 Q1.17. That's the LTS Slim because we're using managed services. And then we run our Helm upgrade using those versions. And now we've actually just deployed Liferay to that cluster that we've created running against those managed service dependencies. So first, we are going to add an internal load balancer just to make sure that we did a little bit of networking stuff here because we wanted to have an internal load balancer to connect to the private subnets. So once we've done that, we'll add those rules to our Helm deployment. And these are idempotent, so you can just run Helm upgrade again with the reuse values argument and add those rules directly. Perfect. And now let's check on our deployment status and make sure that Liferay is actually finishing and getting ready. And once it's ready, that tells us that the probes are succeeding, that they're actually able to ping Liferay through the network. We'll contact our load balancer to actually get the host name that AWS has assigned to us. And there's our randomized URL, which we will now copy and paste into the browser so that we can see whether Liferay is truly running. So here's the moment of truth. Let's go to the browser and paste it. And of course, I wouldn't have put the video in there if it didn't. Beautiful. So now you've seen it. Let's figure out then, what's the answer to that question? What is cloud native? It's two parts. We have the Kubernetes native Liferay Helm chart, and we have the cloud native infrastructure as code. But I'm not just here to teach you what cloud native is, or even to show you what it looks like when it runs. I'm here to tell you why it matters too. So what value does Liferay Cloud Native bring to you? First of all, makes bootstrapping Liferay easy, fast, and repeatable. It also helps you to minimize tech debt by keeping things simple, while actually enhancing your scalability by making your deployments reusable and modular. Speaking of flexibility, by the way, we're working to make Liferay licenses more dynamic, enabling you to change your entitlements on the fly and just focus on usage. Another benefit is that you can leverage the latest tech the cloud industry has to offer, and you own the infrastructure, so you're in control. We're making sure to stay in compliance with all requirements to enable commitment burn down, helping you to maximize value from your existing cloud service contracts. So the time has come to sum it all up in one neat and tidy sentence. So this is what I got for you. Liferay Cloud Native, commoditizing Liferay bootstrapping, enhancing scalability, and putting you in control.